Hey everybody, it's Mr. N here, and we are going to do this review today, which is on derivatives. So the first one is, let's start with the first question. The first question says, find the derivative of the function by using the definition of a derivative f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. Alright, so our first problem here, we have f of x equals 2 minus 5x. So let's go ahead and start with this and see what we end up with. Now on this one, what I want to do is first let's determine what this f of x plus h value is going to be. And that just means I'm just going to put in x plus h right there. So we end up with 2 minus 5x plus h as our f of x plus h value. Now I'm just going to follow this formula. So we have the limit as h goes to 0, and this is f of x plus h, and we know what that is. That's 2 minus 5x plus h minus f of x. So our f of x is this equation right there, 2 minus 5x, and we're going to put that in parentheses because that negative right there needs to get distributed. So all over h. So now let's go ahead and take the next step, and we are going to clean this up a little bit. So on the top, we end up with the limit as h goes to 0, and this will be 2 minus 5x minus 5h minus 2 plus the 5x all over h. So what I did here is I distributed. Alright, so this ends up being the limit as h goes to 0. Now let's take a look at what happens. This 2 and this 2 reduce out. Let's go ahead and change colors here so we can write that in, show you that those reduce out. This negative 5x and this positive 5x reduce out. So the only thing I'm left with is this negative 5h over h. But now look what happens. These reduce out as well, so your final answer is negative 5. Alright, moving on to the next problem here. So for number 2, let's move this up. And on number 2, we've got y equals 4x squared minus 3x. So let's take a look at this and we will see what we got here. So for this one, my f of x is this. So my f of x plus h is going to be 4 times x plus h squared minus 3 times x plus h. So that's what my f of x plus h value is going to be. So now we want the limit as h goes to 0 of f of x plus h, and this is going to end up being this 4 times x plus h squared minus 3 times x plus h. That's my whole f of x plus h term. This is my f of x plus h. And then I need to say minus f of x. So my whole f of x term is going to be this minus 4x squared minus 3x. Again, I want to put that in parentheses because I have to distribute that negative. And all of this is over the h. So let's clean this up a little bit. Now, over here, if I FOIL this out, this x plus h squared, I end up with x squared plus 2xh plus h squared. So we're going to multiply the 4 through, so we end up with 4. Oops, let's write that limit there real quick. So let's go ahead and write that limit as h goes to 0. And this is going to be 4x squared plus 8xh, because I'm distributing this 4 after I FOILed it out, plus 4h squared minus, let's go ahead and distribute this. This is going to be negative 3x minus 3h. Now distribute this one here. This will be negative 4x squared plus 3x all over the h. Now if we did this properly, we should get some things cleaning up here and reducing out. So let's see what happens. Alright, again, this 4x squared reduces with this negative 4x squared. This stays, this 8xh term is going to stay. And this 4h squared term will also stay, but then this negative 3x and this positive 3x will reduce out. So what I'm left with is the limit as h goes to 0 of 8xh plus the 4h squared. So this was left over, minus the 3h, all over h. Well, I could take an h out of the top of everything and reduce it out with the bottom. So this h goes with one of these, and one of those, because I can take it out and it just reduces. Think of it that way. So this ends up being the limit as h goes to 0 of 8x plus 4h. And now take the limit. Plug in 0. That's going to go to 0. And you end up, oh, minus the 3. I forgot minus the 3 right here. I forgot this minus 3. And you'll end up with 8x minus 3 as your final answer. All right, moving on to the next problem. So here we have to find the derivative using the shortcut. This is using that power rule. So let's go ahead and start with these. We'll start with the first one. And this is going to be f prime of x. And again, look at the power rule. We take this and multiply it by the coefficient in front and then subtract 1 from it, which means I'm going to say 3 times the 5 is 15. And then I'm going to reduce this down 1 power. That's the derivative. Plus 2 times the 6. That's 12. Reduce this x squared down 1 power, so I'll get x. And then over here, we're going to say 1 times x to the first is minus 1, so negative 1. Reduce it down so that you end up with x to the 0, which is just 1. And then 1x to the 0, that goes away when you multiply 1 times 0, so you don't have anything there. So let me clean this up a little bit so I can write it for you. This is 15x to the 4th plus 12x minus 1 as your final answer here. All right, moving on to number 4. All right, well, if I just took the derivative here, f prime of x, well, that's a constant. I'm just going to end up with 0. Think of it as x to the 0 power. I multiply it. I'm just going to get 0 there. All right, so now let's move on to number 5. So y prime is going to be 2x minus 2. That will be my derivative there. Okay, moving on to number 6. So over here we end up with y prime, and this is going to be 30x to the 4th, because I multiply the 6 and 5, break it down a power, minus 28x to the 3rd, plus, multiply these, 6x squared minus 9. And that is the derivative there. All right, next one. Well, it doesn't change just because I have fractional powers. The process still remains the same, and we're just going to follow that same process. So over here, I'm going to multiply 3 times the 2/3, and then break that down a power. So f prime of x is going to be 2x. Now, I subtract 1, so I'm going to subtract 3 over 3. That's the same thing as subtracting 1, right? So we end up with, on this one, it's going to be 2x to the negative 1/3. Okay, so then over here, minus. This will be 1/2 times 5, so this will be 5/2 x to the negative 1/2, because 1/2 minus 2 over 2, which is the 1 value. Over here, minus, so this will be 1/3, negative 1/3, and this will be plus 1/3 x to the negative 2/3. And then plus, this is 1 times a 7, so 7. So let me just clean this up just a teeny bit here, and we'll see what we have. We end up with f prime of x equaling 2 over, this is going to be the cube root of x on the bottom, minus 5 over 2 root x. All I'm doing is just rewriting what it says on top. What this is, I'm just kind of cleaning it up and rewriting it a little bit. So this will be plus 1 over, and now this is going to be 3 on the bottom, and this will be the cube root of x squared plus the 7. Okay, so moving on to number 8. Over here we're going to end up with y prime as being, this I'm going to rewrite to be 3x to the 1/2 minus 2x to the 2/3. So when I multiply these out, I'm going to get 3/2 x to the negative 1/2 minus, this will be 4/3 x to the negative 1/3 when I subtract 3 over 3. Cleaning this up, I will end up with y prime as being 3 over 2, and this will be square root x, minus 4 over 3, and this will be the cube root of x. All right, let's move on to number 9 and see what we got going on here. Okay, for this particular problem, we have y equaling 1 over x squared. So what I want to do is I want to rewrite this whole thing to be x to the negative 2 minus 3x to the negative 4 plus 5x to the negative 1/2 minus x to the negative 3/5. So I'm going to rewrite that whole thing like that. Now I can take the derivative a little bit easier. So this will be x to the negative 2, y prime equals 2x to the negative 3 plus 12x to the negative 5, because negative 4 minus 1, plus this will be negative 5 halves x to the negative 3 halves, so I subtract 2 over 2, and then minus, this will be plus actually, minus a negative, so 3/5 x to the negative, I'm going to subtract 5 over 5, so 8/5. Cleaning this up just a bit, we end up with y prime equaling negative 2 over x cubed plus 12 over x to the 5th minus 5 over 2 times the square root of x cubed plus 3 over 5 times the 5th root of x to the 8th. So that is the answer there. Now, on this last one, I'm going to do something a little bit different here, and what we're going to do is we are going to, there's a couple ways to do this. What I'm going to do is I'm just going to break everything up and say this is 2/4 x cubed minus 5/4 x squared. You could put the 1/4 out in front as a constant and then work with it, but we're going to do it this way on this problem. 7 over 4x plus 9 over 4. So I've rewritten this to be like this. Now I'm going to go ahead and take the derivative here, f prime of x. And I'll end up with, this becomes 6/4, which is 3/2 x squared. Over here, this becomes 10/4, which is 5/2, so that's minus 5/2 x, plus 7/4 right here, and then that ends up going to 0. So there is the derivative for this one. Okay, so let's go ahead and move this page out of the way and take a look at the next page. And the next page is going to start with problem number 11. And on problem number 11, we've got write the equation of the tangent line of the graph at the function at the indicated x value. So here's what we need to know for this one, for our little shortcut. The equation of the tangent line means I have to find a derivative at the x value I'm given, and that's going to be my slope, and then I just use y minus y1 equals m x minus x1, and this is my point slope formula. That's the equation of the tangent line. So for this first problem, what I need to do is I need to find the derivative. F prime of x is going to be 10x minus 2. At this x equals 2 value, f prime of 2 is going to be 20 minus 2, which is 18, and that's my slope. Now, I need to know what my x1, y1 value. Well, this is obviously the x1 value, so we need f of 2, and I'm going to plug it in directly right here. That gives me 5 times 4 minus 2 times 2, which is 20 minus 4, which is 16. So what we end up with now when we plug it into our formula, y minus, so again, let's take a look. We've got the point 2 comma 16 is what it goes through. So y minus 16 equals my slope, 18x minus 2. And that's the equation of my tangent line. All right, let's take a look at this next one. Over here, I need to find the derivative. So I'm going to rewrite this to be x to the negative 2. F prime of x is going to be negative 2x to the negative 3. And at x equals 1, when I plug that in, this is going to be my slope. And f prime of 1 is the slope, and that's going to end up being negative 2. Just simply negative 2. So we need to know what f of 1 is. F of 1 is just going to be 1. So we know that it goes through the point 1, 1 and has a slope of negative 2. That's my tangent line. So y minus 1 equals m, which is negative 2, x minus x1, which is 1. And that's the equation of the tangent line there. All right, moving on to this next one. So on this one, let's go ahead and work through it. And we end up with y prime equaling, this is x to the 1/2. Remember that, so that's going to be 1/2 x to the negative 1/2. At x equals 9, this is f prime of 9 is what we're looking for. And this is going to be 1/2 times 9 to the negative 1/2 power. Well, that's 1 over the square root of 9, which is 1 over 3. So I end up with 1/2 times 1/3, which is 1/6. Over here, y of 9 ends up being 3. So I know that it goes through the point 9 comma 3. So there's the slope, there's the point. So f prime yields my slope, and I found my point. So now we're just going to say y minus y1 equals m, x minus x1. All right, let's see what else we've got going on here. Oops. Okay, so let's move this up. I'm going to have to move this out of the way as well, and we'll move that up there. Okay, so use the given function to find each of the following. So on number 14, it just wants me to find g prime of negative 1. All right, well, let's go ahead and find what g prime of x is going to be. In this case, g prime of x will be 6x minus 4. Again, this times this, you got the 6x, negative 4 times 1, and that goes away. So g prime of negative 1 is going to be 6 times negative 1 minus 4. We end up with negative 6 minus 4, which is negative 10. Over here, g prime of 2 is just going to be 6 times 2 minus 4. So 12 minus 4 gives me 8. And the last one over here will end up with 6 times 1/2 minus the 4. So this is 3 minus 4, which yields negative 1. All right, moving on to the next set of problems. Over here, we end up with determine the points, if any. Okay, so for a horizontal tangent, we want the slope, so that's f prime of x, that's my slope. We want the slope to be 0. That gives me a horizontal tangent. If it doesn't have any slope, it will. If the slope is 0, that's what I'll end up with. So we need to find derivatives. In this case, 2 times the 4 gives me 8x, bring it down to power cubed, minus 8x. This is my slope, but I want to know when the slope is 0. So I want to solve this to be 0. So this ends up being, let's take out an 8x, and I end up with x squared minus 1 equaling 0. Let's take this one step further. So my values are x equals 0 and plus or minus 1. That is where I end up with a horizontal tangent. Now take a look at this next one. For this next one, we want to do the same process. We want to find the derivative and set it equal to 0, because the derivative is my slope for this. So y prime, and this is just going to be x to the negative 3, is going to be negative 3x to the negative 4. Well, let's rewrite this. This becomes negative 3 over x to the 4th, and I want to know when this equals 0. Well, does it ever equal 0? No, it won't equal 0, so does not exist. In this case, none. There is no horizontal tangent. If you took a look at the graph of this, this is exponential, and you'll have you'll have an asymptote, but that's not a horizontal tangent line. It's asking for something completely different. All right, and this last one, number 17, let's go ahead and see if we could squeeze this in right here. On number 17, I want to take the derivative, so y prime is going to be 6x squared minus 2x, and set this equal to 0 because that's where I want my slope to be. And in this case, I'll end up with a 2 and an x that I could take out, so I end up 3x minus 1 equaling 0. So this happens at x equals 0 and positive 1/3. All right, hopefully this helped you remember the basics of derivatives. So look it over again if you need to, and good luck. See you in the next video.